In this video, we'll start our discussion about relational model. So what is the relational model? It's a part of the logical database design, which is converting the ERD into relational database models. Now, keep in mind a relation is not the same as a relationship. A relationship is the association between entity types, while a relation is a named two-dimensional table of data. So a relation is, in fact, a table. It will consist of a set of named columns and any number of unnamed rows. An attribute is a named column of a relation. So the attributes that we have and the entities in the ERD are going to become our column names, and each row of a relation corresponds to a record that contains data values for a single entity instance. So the rows are going to represent the instances of a certain entity type. We will have a primary key and we may have a foreign key, and we will discuss both of those. But first, let's look at an example. Now the figure right here shows an employee entity type. It's called employee 1, and then we have some columns which are the attributes that we originally had in the ERD. So the attributes that we had are employee ID, name, department name, and salary, and these are representing the columns right here. Each row of data is corresponding to one of the instances, and in this case we have 5 instances. Now when we model a relational model, we will not have the data in there, but in this example we just have the data to show the overall picture. Now how can we model this in terms of a relational model is as follows. We can express the structure of a relation by using a shorthand notation in which the name of the relation is followed by the names of the attributes in that relation, and we place those in parentheses. Now this is not the only way to represent it. We can represent it as the table header, as we will see in some more upcoming examples. But for the previous table, this is the relational model shown in here. We have the table name or relation name, and then we have all the attributes included in there. Now there is something missing in this, which is the primary key that we will discuss in the next slide. We must be able to store and retrieve any row of data in a relation. So every relation must have a primary key, which is an attribute or possibly a combination of attributes that will uniquely identify each row in the relation. And in this case, employee ID is going to be the primary key, and we will represent it by underlining the primary key with a solid underline. The reason I said a solid underline is because we have a different type of key, which is a foreign key, that is going to be represented by a dashed underline. Now there may be several attributes of an entity that may serve as the primary key for that relation, and in that case we will need what we call a composite key. Now a composite key is a primary key that consists of more than one attribute. If you recall, when we talked about flights, we said the flight number combined with the date is the primary key for that entity type, and therefore it's going to be the primary key for that relation or table. Now we have another example when we have an employee entity type and a dependent entity type. This would likely have a combination of employee ID and dependent name to represent the primary key for the dependent table. Now the other type of key is the foreign key, and often we must represent the relationship between two tables or two relations, and sometimes this is accomplished through the use of foreign keys. A foreign key is an attribute, again, or possibly a composite attribute in the relation that serve as the primary key of another relation. So it has to be the primary key of another relation, and we will include it in that relation as a foreign key. Now, if we look at this example where we have employee and department, we'll have employee having the department name, which is a primary key in the department table. Now, this did not highlight it in a dash underline, but we will need to include a dashed underline in here to show that this in fact is a foreign key for that relation. And this is how we represent the foreign key that is going to relate to another primary key. Remember, a foreign key is an attribute in a relation that is a primary key of another relation. As we can see here, the department name is the primary key of department. Now this will link the employee table to the department table and will allow us to have the department name for each employee to show that this employee works for the department. And as we said, this is going to be the foreign key that allows us to associate those two entities. And what we will need to do is to include an underline in there. Now let's look at the properties of relations. First of all, each relation or table must have a unique name. And then there can be only one value associated with each attribute on a specific row of a table. We cannot have any multi-valued in the relational model. So we'll have to deal with multi-valued attributes in a different way than we had in the ERD. Remember, in the ERD, we just placed the notation of the multi-valued attributes, and then we just move to the rest of the attributes. In a relational model, we will see how we can deal with those. Each attribute or column within a table must have a unique name, which translates to that we cannot have two attributes with the same name in the same table. Each row is unique. We cannot have two rows in a relation that are identical, and this is going to be accomplished by having a primary key which cannot be repeated for multiple records. The sequence of columns left to right is insignificant, and the sequence of rows top to bottom is also insignificant. We will see later on when we program the database or when we write the code for the tables that these will not matter. Now, how can we go from an ERD to relational model? First of all, entity types in the ERD will represent the tables or relations in a relational model. And as we said, in the ERD we cannot have two entities with the same name, and that is the same thing in relational model. We cannot have two tables with the same name. Entity instances in the ERD are going to be the rows in the relational model. Attributes in the ERD are going to be represented by columns. And note again, the word relation in relational database models is not the same as relationship in ERD. We'll have primary keys that will guarantee that all rows are unique, and we will have foreign keys to establish the relationship between relations. Now let's look at an example. Suppose that I have this ERD. I have customer, order, order line, and product. And then I have some relationships and I have some attributes in there. Now this is going to be translated to the following model. Now this is another way to represent the relational model. You can just have the headings of the tables, which is going to be a relational model. This is one representation, and this is another representation. Which one is better? It's just your personal preference. Both of them are representing the exact same thing. So you can use the top representation or the bottom representation, which is totally up to you. Now, the bottom representation is useful when you want to write it in a text editor, like a TXT file or any text editor that will not support any sort of tables or graphics. Now we will talk about mapping ERDs to relational models, and we will talk about entities and attributes. These are the things that we need to consider. We will also be considering weak entities, and for relationships, we'll have different cases for one-to-one, one-to-many, and many-to-many. And then we will have some mapping for unary relationships, binary relationships, and ternary relationships as well. And finally, we will see how we can map supertypes and subtypes.